Hello and welcome to the next video on your GCSE practical investigation. This will be looking at strands RA and RB, the final two strands of your... Okay, so the aims of the video is to explain what the OCR mark scheme says for strands RA and RB, and to look at the types of secondary data that you can include in these strands and how to integrate those into your report. So again, as in the last video, here are your strands in the detail mark scheme. We're looking to compare your primary data with at least one piece of secondary data and comment on it. Okay, in particular, 3 and 4 marks, you're looking to identify details in the similarities and the differences. Okay, and we're looking to reference. We'll talk to you about how referencing works as we go through. Particularly 5 and 6 marks, okay, you're looking to describe and explain the extent to which the secondary data supports, extends or adds to your primary data, or sometimes you'll find that it undermines or kind of goes against your primary data. It's good to spot any areas of incompleteness in both the secondary and your primary data, and you'll be looking to collect lots of secondary data from fully referenced sources. Okay. For RB, we're looking to refer constantly back to our hypothesis or our predictions, and our predictions ideally. Okay. And we're going to look to see how the data supports what we've written already, or how it cuts across what we might already have learnt. Important thing to note here, this is the strand where spelling, punctuation and grammar comes in as well, so you should go through and check your spelling, punctuation, grammar, and even your organisation of your account. If you have a look here, information is organised effectively, okay, and using science terms. Let's go back to our experiments. Remember what we were doing. My general hypothesis was that LDRs would change their resistance depending on the amount of light shining on them, or the intensity of light ideally. The aim of my investigation was to see how changing the distance between the light source and LDR affected the resistance of the LDR. So it's linked in with my hypothesis, but not exactly the same. And my quantitative, my prediction with my values in, okay, said that doubling the distance between the lamp and the LDR would double the resistance of what the LDR read. Okay, we moved our light bulb around, changed the resistance. My results, and we want to comment on what's similar or different between our results and other people's. So, just to remind you, this is what the graph looked like. General trend is we had a straight line. As the distance increased, the resistance increased as well. And we felt fairly confident. Lots of small range bars, so our results were fairly repeatable. All the x's lied close to the belt line of best fit, so they were accurate as results go. But we want to compare to other people now. So, what types of secondary data could there be? Well, we don't just have to have tables and graphs. We can also compare what we found in our experiment to other explanations. We can sometimes use formula, and in particular you could think about using diagrams to help explain what you found in your primary experiment. So we could comment on other people's data, other students. This would probably be one of your first places you look, alongside the extra data sheet given to you by the exam board. So you could comment on the number of repeats they did. You could comment on their range of results. How many independent variable values did they choose? You could also comment on their accuracy in exactly the same way as you did for our primary data. You could very quickly comment on, does their general trend follow your data? So if they did the same experiment, if they changed the distance and measured the resistance, you can check to see, as the distance went up, does their resistance also go up, or does it actually trend the other way? Even more importantly though, as we're looking at this strand R, we've got to refer to our hypothesis. So remembering that our hypothesis was that the more light that shone on an LDR, the lower its resistance would be. Okay, so here we go. We're looking back carefully, constantly referring to our strands. We want to compare our experimental results with at least one piece of secondary data. So I'm going to switch to another document here. This is data I've collected outside of my write-up session. Okay, and we're going to see what have we found. So here's my document. I found a few pieces, okay, a few web pages for me to talk about. I wouldn't be able to take this in because I've written extra notes in to help me write my report, but I could still prepare this and have this in my mind as I went into my write-up sessions. What I am allowed to take in is a sheet that looks like this, which has the data, quotes in, and details of where I found them. So, to start with, here are results from another group of students at my school, probably from your class, and they did a very similar experiment to the one I did. They changed the distance between the light bulb and the LDR. Okay, they also went up in 10 centimeter intervals, but different to mine, they only did a range between 30 and 70, whereas we did a range between 30 and 90. So they've only got 5 data points, whereas we had 7. And their resistance, they only measured 3 times each, so they repeated their results less often. So we can comment on their repeatability. They did take averages, so we could plot a graph if we so felt. However, without even plotting a graph, it's clear to see here that as the distance increased, went from 30 up to 70, the average resistance also increased. So their trend we're expecting should follow our line of best fit. Should be similar. It might not be exactly the same values, but should be similar in the trend as to what we'd found with our experiment. If I want to check this, I could plot the graph, but I don't have to. Okay, the other thing that we could do is we could use other explanations. So here, BBC Bite Size, it's based on the course that you are studying. Here we go. So this is the web page I had. I've given the full web address so that the examiners can check it. Thereafter, referencing that means that they can actually follow up and check to see if you've copy and pasted large chunks. So here, thermistors, LDRs, very brief section. This is an LDR, that's the piece of equipment we used. They used to detect light levels, so that's helpful. And their resistance decreases as the light intensity increases. So that's very similar to what we wrote in our hypothesis. So this seems to be supporting what we'd said in our hypothesis. In particular, I was quite happy with this line. In bright light, the resistance to the LDR was low, and therefore more current could flow through. In fact, I liked it so much that I put it in my document. Here we go, secondary data, and I highlighted it, put it in quotes to remind myself that I was going to quote that line. Mentioned who was it written by, BBC Bite Size. What was the full web address? There's the long one. I've removed the underlining so I can see where the underscores are. And finally, I've said when did I access it, because sometimes web pages go down, sometimes they're removed. So if I've said when I've accessed it, we can check to see whether or not things have been changed in that time. Okay, I actually used another BBC Bite Size section here, so I could call that, if I wanted to, BBC Bite Size 2, so that I don't get the two references confused. And again, I've got that here. Okay, I've actually put a diagram in. Here it is, electromagnetic radiation, about light spreading out. So why does the light intensity change as I move my source further away? Well, the further away you are from the light source, like my light bulb, the more spread out and therefore the less intense the beam becomes. This is quite a useful diagram. I could use it to help my explanations. So I could use it as a piece of secondary data. It's not a table, it's not a graph, but it does support my hypothesis. In particular, it says here, as the photons spread out from the source, they are more thinly spread by the time they reach the detector. So I can imagine putting my detector or my LDR in the middle of one of these light patches. When it's close, the light is intense. When it's further away, the light is less intense. Okay, so it doesn't mention LDRs here, but it helps me with my explanation. I could include it. Right. So I've put those in here. In fact, I've written myself a few notes to remind myself what I could do that. Checking my spelling, punctuation and grammar as I go along. They are compare. Again, who wrote it, the author, when did I access it, what was the source, etc. Particularly, I wrote myself a few notes to remind myself, so it's fresh in my mind, what I was going to use that data for. Does it support, undermine, or extend my data? Okay, these two together help explain why the resistance changes. Firstly, we said the bulb moving changes the light intensity, and secondly, the LDR has a lower resistance when there's bright light. Okay, again, I'm not allowed to take this in, but I could study it and use this as revision, essentially, before I went into my session. I've also found another source. This one actually had some data in, and I'll show you that now. Okay, so I was on Google. I was looking for something helpful, so here I searched for some raw data. LDR resistance against distance, and I found some A-level results. And after reading through carefully, here we go. We looked at their experiment. Their experiment is extremely similar, in fact exactly the same as the one I did. They moved the lamp to an LDR, measure using a ruler, and what they did, rather than measuring the resistance directly, they measured the current. So here they've measured the current in milliamps when they've changed the distance. They got a lot closer, so they got down to 5 centimeters, but they only went up to 40. They went up in intervals of 5 centimeters, whereas we went up in intervals of 10. So they should get a fairly good best fit line. Okay, so their results they've mentioned here, they've summarized. As the distance increases, the current decreases. In fact, they've also mentioned that they've kept the voltage constant. So, as the distance increases, so does the resistance. That's what we said for our results. As the distance increases, so does the resistance. This could be used to support our primary data and increase our confidence in what we've said for our hypothesis. Okay, I don't need all of that. It goes on for quite some time, and there's lots of graphs, so I'm going to be selective about what I include. So in my document, okay, secondary data from a group of students, brief quotes and diagrams potentially from BBC, and finally, here it was, Brooks Heath Science blog. There's the full web address, when I accessed it, and the data that I've taken, so their table. Okay, and there was their little blurb about what their results showed. So I'm going to make sure I put that in quotes, because I'm going to use it as a quotation, if anything. I can't just copy and paste it in without acknowledging that it was somebody else's work. Okay, and I'm going to use this little section here that says, okay, they said, as the distance increases, so does the resistance. That's the main thing I want to include, so highlight it here for myself. Make navigating my notes and anything I take in very quick and easy. However, I want to say good luck and hope you find this a little bit useful. Take care.